Hi everyone, I'm Krystal and I've been working as a creative coder for about 12 years now. During this time, I've had the opportunity to do a little bit of everything from web and mobile application development to 3D modeling and VR. I'm also part of the Insights team at Shopify where we create awesome data visualization experiences together. Today, I'll walk you through some of the techniques that I've learned along the way so that you can create your own performant animations and the data viz with React. If you have any doubts, questions, or suggestions, I'll be available to answer them by the end of the talk, or if you're not watching this live, feel free to reach out to me on Twitter. My username is Krystal Campioni. Before we actually start talking about code, there's one topic that I always like to cover because I think it's really important. Motion is a message. If you think about it, in real life, things don't, just pop in your face because it would be really scary if they did. Instead, what happens in real life is that things move from one place to the other, like this furry monster walking in real life from one side of the screen to the other. The thing about motion, though, is that when used wrong, it can actually make the experience worse. So let's have a look at this example. Like almost everyone, I've been obsessing over COVID-19 data since the beginning of the pandemic. And as I live in Canada, I always come across this one from a Canadian newspaper. Notice how when we switch from total to breakdown, the area representing the total slides down and all of the areas representing the layers of the breakdown slide up. This makes it hard for my brain to understand what the relationship between the breakdown and the layers of the layers of the breakdown and the total is. It should be clear that the breakdown is formed by deaths, recovered, and active, but because everything is moving at the same time, it seems like both of the data sets are not related at all. So let's compare this with an alternative. In this example, instead of sliding everything down and up again, we just keep the total number of cases, the area representing the total number of cases always there, and then we slide up and down just the layers forming the breakdown. It feels that the relationship is a bit clearer, but to be honest, this is a perfect example of when using fancy animations is not ideal. So let's compare it with a final alternative. Here, when switching between total and breakdown, we have a simple fade that reveals and hides layers of data. This is great because it makes it obvious that these layers sum up to form the total. My brain does not have to follow some lines moving randomly around to try to understand what's going on. It's just there. There are, of course, situations where motion can help us understand what's going on. So let's have a look at another example. Here we have a chart that compares the numbers of sales from this year with the same period of last year. We can choose with which period we'd like to compare, this week, this month, or this quarter. Notice how when comparing this quarter to last year's quarter, the line is red because the total number of sales in this quarter was lower than last year's. But when we switch to this week, the line becomes green, as this week compared to the same week last year had more sales. The animation here helps us understand that the data lives in a timeline. When we choose a period to analyze, we zoom into that period in the timeline. Another interesting example. This chart shows the number of page views in the last 10 minutes. So we have 10 bars, 1 bar for each of the minutes, and the bar for now keeps growing as it receives new data. When that last minute is completed, a new bar appears and pushes everything to the side to make way for itself. Once again, the motion here is like reinforcing what's happening with the data set. All right, so let's start talking about how we can create some custom data visualization from scratch. Recently, we were exploring how to represent the customer behavior data of people accessing Shopify stores. So this was our initial draft. The idea here is that we would have all of these moving particle buckets for people that were with active cards or checking out or that already purchased something in the last 10 minutes. It would be super cool if we could see all of these particles swimming in there and jumping from one petri dish to the next one as people progress through the sales funnel. The problem was that we could not actually track what each individual was doing. Instead, the data that we could get for this component looked something like this. As you can see, we only have a number for each of the buckets. No way of knowing which one of the little microbes jumped from one petri dish to the next one. So maybe we could implement an animation of the microbe jumping from a random direction into a bucket when the number increases. It seems like a good idea, but this could get really, really messy if we had like hundreds or thousands of people accessing the site at the same time. I mean, this looks kind of cool, three evil blobs floating around, but it doesn't actually help me understand how many people are at each step or how the flow is going. So this was not going to work. So this is our second draft, and I think that this one is actually much better. We have three circles with different sizes that are easy to compare, so we can quickly know if we have more visitors with active carts or people that already purchased something, for example. And we can make it work with our data as well. So let's say that the first time we receive the data, total checkouts is 15. The next time we receive it, total checkouts is 17. We know for sure that the number incremented by 2, so we can trigger an animation of 2 running dots going from the active cards bucket to the checking out bucket. And we can do the same thing if the number of purchases increases. So let's see how we could use SVG and Z3 to implement that chart with React. So the first thing that we should know is how we can implement it with D3, because that's the library that we're going to use for all of the math calculations. And we have all seen fantastic examples of things that can be built with D3. It is super cool, but it can be a bit overwhelming to know where to start. I mean, this is a screenshot from their D3's API reference from their GitHub docs. Look at the size of this thing. D3 is a really complete tool. It has all sorts of methods that you can use to treat data, bind it to the DOM, and etc., etc. But since we're using React to do all of the DOM manipulation for us, let's define first what we should not use from D3. Things like D3 selections. This module works in a similar way that you would expect from something like jQuery, by selecting DOM nodes directly and then transforming them based on the data set. We do not want to use this module, as we'll be letting React do what it does best, take care of the virtual DOM in a performant way, and instead we will use D3 for what it does best, for being a toolbox for helping us with math utility functions and layout calculations. So no D3 selections. A perfect example of the type of things that we are going to use is D3 scales. Scales are functions that map from an input domain to an output range. So if we look at this example in code, it would be something like this. We have an input array with some sample data. We can then use D3's extend function to extract the minimum and maximum values of that array, in this case 0 and 500. And we can then use a scale linear function to map those values into pixels so that we can render them in the available screen space that we have. D3 scale functions actually return a new function that we can call to convert values from the input array into whatever it is that we are trying to use. So in this case, we're trying to convert it to pixels. To represent the horizontal distance from the left side of the screen until the position of each of those circles. So in this specific case, we can call the xScale function, which is the function that we get from calling the D3 scale linear. And the first time that we call it, we pass in 0 and then retrieve 0 pixels. And then we pass in 250, which is a value from the input array, and retrieve 170 pixels. And then we pass in lastly 500 and retrieve 330 pixels. Once again, we are just converting the raw values that we have from the input array into the available screen space that we have. And we are using those pixel measurements to define the CX position of each one of the circles. So going back to the customer behavior chart, now that we know how scales work, we can explore how to change the size of the circles using a D3 scale. The first example that we saw was a linear scale, but using linear scales for calculating the radius of a circle is not the best, because we humans, we tend to interpret the area to actually be the reflection of the data. So instead of using a linear scale, we should use scale square root, so that the area of each circle is what actually reflects the value that it represents. We can then use the radius scale to calculate the radius of each circle depending on the data. This is nice, but we are not animating the radius changes yet, so it doesn't look super smooth. Let's fix that by plugging in React Spring. To do that, we first import useSpring animated and config from the package. Then we set up an animation with the useSprings hook. It works kind of like this. The first argument is the number of springs or animations that we want to create. The second argument is a list of objects describing each animation. It is here where we tell React Spring what properties it should watch for changes in order to animate. In this case, it's the radius property, where we are using the radius scale to get the value based on the data points. The config is where we define the characteristics of the animation using Spring physics, things like mass, tension, friction, etc. Config.molasses is just one of the defaults that we get from the package. If you'd like to learn more about how Spring Physics work, I highly recommend you read this article by Josh Kumul called A Friendly Introduction to Spring Physics, which you can find on this link, bit.ly/springphysics, spring-physics. Once we have the radius springs prepared, we just have to render it. So for that, we replace the regular circle tag with an animated.circle tag. And instead of calculating the radius directly, we get the radius from the radius spring.